Okay, so in this video, we'll be discussing the pure mathematics 3 paper 3, okay, from October, November 2021. Okay, so question number 1. We are given the equation, and then they want us to find the value of x, and we have to leave our answer in this form, log a divided by log b, and a and b are actually integers. Okay, so starting from what they give us, okay, we are going to solve the equation here. 3 multiplied with 2 power 1 minus x equals to 7 power x. So to get the value of x, basically I need to group all the x at one side. So now from here, you can see that we are having x at both sides, right? So I need to rephrase my equation so that I'm having all the x at one side only. So 3 is 3, then multiply by 2 power 1 minus x. What am I going to do is I want to separate them, become 2 power 1 multiply with 2 power negative x equals to 7 power x. Okay, so I think this one you should know. We are actually applying the property of indices, where if I'm having 2 power m plus n can be written as 2 power m multiplied with 2 power n. Okay, so we are actually applying this property in the indices. All right, then 3 multiplied with 2. So 3 multiplied with 2, they are pure numbers, so I can have a 6 here. Then 2 power negative x, I can rewrite it become 1 over 2 power x equals to 7 power x. And if I bring this 2 power x over to the right hand side, I'm having 14 power x. So again, from this step, what is the property of indices that we are using? So basically, we are using a property where if I'm having a power m multiply with b power n, which means that both of these two numbers are having the same power, you can basically combine them, become a multiplied with b power n. So I'm having 2 power x multiplied with 7 power x, right? So they are having the same power. Therefore, I can multiply 2 with 7 together, become 14. Okay, so to get the value of x, I need to take ln or log both sides. So for this question, since they are asking us to leave our answer in this form, ln a divided by ln b, therefore I will take ln for both sides. So I'm having ln 6 equals to ln 14 power x. So the power x inside the ln, you can actually bring the x, the power in front, become a number. All right, so I'm having ln 6 equals to x ln 14. So by grouping only the x on the left hand side, all the number to the right hand side, so I'm having ln 6 divided by ln 14. And you can see that this is actually the pattern that the question wants us to show. Okay, so our answer for x will be ln 6 divided by ln 14. So you double check the request for the question. Okay, so 6 is the n, is the integer. Then b is 14, which is also the integer. So which means that very likely our answer for this part will be the correct answer. Okay, so this is how we answer question number. Okay, so question number 2. They want us to solve the inequality, this one, okay, where a is a positive constant. Alright, so if you look at this inequality, right, basically we can observe that there are modulus function at both sides. So to solve this kind of equation or inequality, where we are having modulus on both sides, one of the method is you can square both sides, okay, and then you continue to solve the inequality. So to square both sides, I'm having 3x minus a and then square. When you square both sides, the modulus function disappears. So you become 3 minus a and then with the square greater than the number 2. Okay, so number 2 you have to square it also. So I'm having 2 power 2 and then modulus function disappear, x plus 2a then square. Alright, so once I square both sides, then I need to expand the equation both sides. So by right, you should have something like this. I'm having 4 on this part, and then x squared plus 4ax plus 4a squared. Okay, then further simplify them and group them together at one side. Okay, so from here, if I group everything on the left, I'm having 5x squared, then minus 22ax, then minus 15a squared greater than 0. Okay, so before I can solve this inequality, I can see that we are having the quadratic form equation right on the left. So to solve this inequality, I want to get the value of x first, which is a critical value. All right, so to get the value of x on this side, what am I going to do is, I will assume that I will let this quadratic equation equals to 0 so that I can get the value for x. Okay, since this is a quadratic equation, right? So you can try or attempt to factorize them. And this equation can be nicely factorized. I'm having 5a here. Then this is 3a. So minus 5, minus 25 plus 3a. Okay, so from here, you have the critical value x. So x equals to negative 3a over 5 or 3 over 5a. And then another value is x equals to 5a. Okay, so I will call this as critical values for the x. Okay, so after I get the critical value for the x, to solve this inequality, what am I going to do now is I will want to draw the number line. Okay, so I will want to draw the number line. And then this value x is smaller, right? So I'm having negative 3 over 5a here. And then x equals to 5a is larger value. So I put it on this part. Then for the bracket, it is positive, right? So both brackets should be going to the right. So for x greater than 5a means that when x is greater than 5a, this particular bracket is positive. Therefore, I draw the arrow to the right hand side. Then when x is more than negative 3 over 5a, this particular bracket is positive. Therefore, you can see that on this line and this value, when I draw it to the right hand side, it means for all this value here, okay, when I put it inside this bracket, this particular bracket is a positive bracket. Okay, so where we're having the part with the line, it means positive. The part without the line means negative. So if I simplify everything here, you can see that this is my number line obtained. And in this question, we are interested for the value of x where your quadratic will be more than 0. So if quadratic more than 0, that means you want to take this part, which is overall positive, and also take this part, which is overall positive as well. Therefore, your final answer for the x that makes the inequality correct is x smaller than negative 3 over 5a and also x greater than 5a. So this is the solution that we have for this particular question. Alright, so please take note that for number line, it is not the only way for you to decide what is the answer that you want. Some students might want to use the table of sign, which is quite similar to what we have here. So it is also, you can also apply that method if you want. Alright, okay, so this is how we solve question number 2. Okay, so come to question number 3. We are given the complex numbers now. We are having u equals to a plus bi, w equals to c plus di, and all the ABCD are real. They want us to prove that u plus w star equals to u star plus w star. Okay, so first of all, what we need to know is what is the meaning of the star here. Okay, alright, so before we start, you just need to know that if let's say when I'm having u equals to a plus bi, right? So the meaning of star basically means that we are going to change the imaginary part become the opposite sign. So as an example, if let's say u equals to a plus bi, so what is the meaning of u star here? Or u conjugate? So u conjugate will be a minus bi or ib. So you are actually changing the sign of the imaginary part. So that's the meaning, general meaning for the conjugate here or the star sign here, right? So they want us to show that when we are having u plus w star, it can be written as u star plus w star. Okay, so first of all, I want to start from the left-hand side here. Okay, so left-hand side, I'm having u plus w star. So what do I have for u plus w? So u is actually a plus bi, right? And then w is c plus di. And then I'm having a star here. Okay, I want to group all the real part together. Real part means without the I1. So I'm having a plus c without I. And then all the I together. So I'm having b plus d and then I. Okay, so you can see that this is a real part, this is an imaginary part. So when I'm having a conjugate here, it means that I want to change the sign of the imaginary part. Okay, so for the conjugate sign here, so that means if I apply the conjugate sign, then the plus here will become minus, and then b plus di. And the conjugate disappeared after I change the sign for imaginary part. Okay, then again, how can I rephrase it become u conjugate plus w conjugate? You just need to rephrase your equation here. So I'm having a minus bi and then plus c minus di. Expand everything. Okay, so this one multiply inside the negative. So you rephrase it again. I'm having a plus bi, a minus bi plus c minus di. And then you can see here, what is the a minus bi here? Our u is a plus bi, right? Therefore, a minus bi can be written as u conjugate. And also for the w, our w is c plus di. So c minus di basically can be written as w conjugate as well. So you can see very clearly that this is actually the right-hand side of the equation. And this is what they want us to show. Okay, then next we continue to part number B. Okay, so now for part number B, they want us to solve this particular equation, and then our final answer is in the form of x plus iy, where x and y are real. Again, if you look at this equation, right, I'm having z, and then they are telling us that z, final answer for the z should be in the form of x plus yi. Basically, it means that this is a complex number equation, right? So your final answer will get a complex number. Okay, all right. So from here, you know that this is actually your z. So z equals to x plus iy. To solve this equation, I need to copy what they give us first. So I'm having this equation, then plus 2 plus iz equals to 0. Since I know that my final answer for the z will be a complex number, right? X plus yi. Therefore, I substitute here into my equation first. So I'm having x plus yi, which is the z, then plus 2 plus I conjugate. Then also same thing apply here, 2 plus I, and then the z will be x plus yi. That equals to 0. Okay, so you can see that x plus yi is a z, and then 2 plus I seems like it's another complex number, right? You can use the result that we have here just now. U is one complex number plus W is another complex number. Conjugate can be written as U star plus W star. So same thing happened for this particular bracket here. X plus yi is maybe like a U or the Z. And then 2 plus yi is another complex number. Therefore, when you apply conjugate here, you are having x minus yi, then plus 2 minus I. Okay, so basically this particular step, I'm using the result from part 1. Result in part number 1, or part A, sorry. Okay, and then after that, for the second term here, what we need to do is like we just expand it. So to expand it, I just expand the bracket. So 2x plus 2yi plus xi, then minus y. Originally should be plus yi squared. So I squared is negative 1. When you multiply inside the y, I'm having negative y here. Then equals to 0. Okay, so to continue and solve this equation, right, to get the value for x and y, I need to group all the real number together, all the real part together, without the I1. So I'm having x plus 2 plus 2x plus minus y. So if I group all the highlighted term here, basically I will have 3x minus y plus 2. Okay, so this is how I group all the real part together. And now I want to group all the imaginary part together. Imaginary part means that something with the I1, right? So I'm having negative yi minus I plus 2yi plus xi. So if I group all these blue highlighted term together, okay, by right I will have x, then plus y minus 1, and then I take out the I. Okay, so I put the I at back on bracket and then equals to 0. Okay, so you can see that I'm having a complex number here. So this is a real part, this is the imaginary part. So on the right hand side, it is equals to 0. 0 means basically it is 0 plus 0i. So you are trying to compare it with 0 plus 0i on the right hand side. Okay, so from here, you can see that real part is this one, equals to 0. So from here, I can form the first equation, 3x minus y plus 2 equals to 0. And then y equals to 3x plus 2. I can assume this as first equation. And then for the second equation, you can try to compare it by using the imaginary part. X plus y minus 1 equals to 0, right? Okay, so x plus y minus 1 equals to 0. And of course, your y equals to 1 minus x. Alright, so I think from these steps onwards, it is quite obvious. If you want to solve this particular equation to get the value for x and y, you have to solve them simultaneously. Okay? Alright, so how to solve them simultaneously? You can let equation number 1 equals to equation number 2. So 3x plus 2 equals to 1 minus x. So 4x equals to negative 1. And your x is equals to negative 1 over 4. And of course, you need to substitute it into the equation, and by right, you should be able to get the value of y. You can substitute x into any equation here, either number 1 or number 2. Alright, so if you substitute it and without careless mistake, by right, your answer for y should be equals to 5 over 4. Okay, so from here, this is how I get the value of z. Right, so z is the root of the equation. So z equals to negative 1 over 4, then plus 5 over 4i. Z equals to x plus yi. Okay, so this is how we basically solve this equation with which involve the complex number. Right? Okay, so let's discuss question number 4 now. They want us to express this fraction into partial fractions. Okay, so first of all, we need to check whether this given fractions is improper fractions or proper fractions. Okay, so first of all, how are we going to check whether it's improper or proper fraction? So we need to check the degree of numerator and denominator. The highest power of the numerator is 2. Therefore, the degree for numerator equals to 2. And for the denominator, if you multiply x and x together, right? Okay, the power that you get is also 2. So the degree for denominator is also equals to 2. Okay, when you are having the power of numerator and denominator are equal, or the degree of numerator is greater than the denominator, basically this kind of fraction, we call them as improper fraction. So to find out the partial fraction from an improper fraction, right, you need to actually apply, or maybe you need to change it or make it become proper fraction first before you can find out the partial fraction. So how can we make this improper fraction become fraction? Become the proper fraction? We have to apply long division. Alright, so the numerator is 4x squared minus 13x plus 13. And then try to expand this denominator, and then your divisor, it will become a divisor in a long division. So I'm having 2x squared minus 7x then plus 3. So again, to get this particular term, you expand the denominator given in the fraction. Alright, then we will start the long division now. Something multiply with 2x squared equals to 4x squared. So the something should be a 2. So that I'm having 2x squared multiplied with 2 and have 4x squared. Same thing happened for the second term. 2 multiplied with negative 7, I'm having negative 14x. And then 2 multiplied with 3, I'm having a positive 6. Then I will take the term on top minus the term at the bottom. So 13, negative 13 minus negative 14, I'm having positive 1. 13 minus 6, I'm having positive 7. Okay, so after you apply the long division, right, then the remainder over the divisor now will become our proper fraction. Okay, so we can actually expand, okay, or try to find out the partial fraction from the remainder. Okay, so that means our proper fraction will be x plus 7 divided by the denominator 2x minus 1 and also x minus 3. So 2x minus 1, x minus 3. Okay, then if I want to expand it, right, I'm having a over 2x minus 1 and then b over x minus 3. Okay, make the denominator disappear. To make the denominator disappear, I try to multiply the whole equation by the original denominator. Okay, then this is, after simplifying, then this is what I get. Okay, so you can try to imagine, okay, for this equation, for this particular term, I multiply with 2x minus 1 and also x minus 3. Therefore, you cancel off everything. Then for this particular term also, you multiply it with the original denominator. So 2x minus 1 and 2x minus 1 can be cancelled. Therefore, you're having a multiplied with x minus 3. So the same thing applies for part B here. Okay, all right, then now I want to find out the value for a and b in my partial fraction. Okay, there are many ways also for you to find out the a and b. You can expand it and then you compare, okay, the coefficient for x and also the constant term. Then for me, I just want to eliminate the unwanted unknown. So first of all, I will look at this particular bracket. I want to make this particular x minus 3 bracket become 0. So I have to let x equals to 3. So that when I put 3 inside this bracket becomes 0 and a will disappear for this at this value. Then I can find the value for b. Okay, so I will let x equals to negative 3. Substitute 3 inside here. So 3 plus 7, you get a 10. 3 minus 3, you get a 0. Therefore, no more term in this part. And then substitute 3 inside here. 3 times 2 is a 6 minus 1 is 5. So I'm having 5b. So from here, very easily, you can see that the value of b is equals to 2. Okay, so after you found the value for b, now you want to find the value for a. Okay, to find the value for a, you need to make sure that you make this particular bracket become 0. How to make the bracket 2x minus 1 become 0? You have to let x equals to half. And if you substitute half into this equation, into this bracket, the particular bracket here will become 0, right? Then you can continue to find a. Okay, right. So now substitute half into the equation from the beginning. So half plus 7, you are having 15 over 2. Substitute half into this bracket, half minus 3, you are having negative 5 over 2. So negative 5 over 2 and then a. So from here, you will get the value of a very easily as well, which is equals to negative 3. Okay, all right. So now I already find out the long division. Okay, so the quotient, I have used the remainder to find out the partial fraction here. Therefore, to write out the final answer for the whole equation, it will be something like this. So this is my original fraction. So 4x squared minus 13x plus 13 divided by 2x minus 1 and also x minus 3 equals to, okay, so what is the quotient? The quotient that we get from top is 2, right? From the long division is a 2. Okay, then minus, after that I'm having this, so can be separated, become these two partial fractions. So a divided by 2x minus 1. A is negative 3. Therefore, when I write out, it will be negative 3 divided by 2x minus 1. And then what's the value for b? B is 2. Therefore, I'm having 2 divided by x minus 3. So this is how we actually get the partial fraction from an improper fraction. Okay, all right. And then for this question, before you want to find the partial fraction, right? Don't always forget to check whether your question here, is it belongs to improper fraction or proper fraction. I think there are a lot of students, right? They usually didn't check. So they'll straight away try to proceed, okay, to the step to find the partial fraction, which is wrong. If you're having improper fraction like this, you have to change it become proper fraction first, okay, by using the long division. And after that, only you can get this proper fraction and change it become the partial fraction. All right, so this is a small details that you need to know or you need to check before you can start answering this question. All right, so this is how we answer question number 4. All right, so now let's discuss question number 5. They want us to, on a sketch of Argand diagram, they want us to shade the region that the point represent the complex number z satisfying the inequality for these two. So we are having two inequality here. Okay, so first of all, the first inequality, I'm having the modulus on the left hand side. then this is original inequality that I have. Okay, so to sketch the inequality, right, basically I need to have the standard pattern where z minus a complex number is smaller equals to 1. Okay, so if I want to write, become z minus a complex number, okay, smaller equals to 1. So if I take out the negative from both value here, by right, the complex number will become 3 plus 2i. Okay, and then when we are having the equation, okay, with the complex number, one side with modulus and the other side is a number, in general, it is actually a circle. The locus that you are drawing is a circle, and then with the radius here. So maybe you should know that this is actually the radius of the circle, and then the center of the circle will be this one, which is 3 and 2. Okay, all right, so this is the first inequality that we need to draw. Like later, it will be a circle. And after that, the second inequality is imaginary part of z is greater equals to 2. So what is the meaning of imaginary part of z? Okay, if let's say I'm having a complex number z equals to x plus yi, so the x here, we call it as real part of z, and then the y is actually the imaginary part of z. Without the I, okay, so the imaginary part of z will be the y, which is the coefficient of I. Okay, so in short, imaginary of z means that y greater equals to 2. So these are the two inequality that I need to draw. Okay, so first one is a circle with the center 3, 2 and radius 1. And the second one is y greater equals to 2. Okay, so I'm going to sketch the diagram now. They provide us the space here, right? So to sketch this diagram as accurate as possible, you might need to try to use a ruler to measure the ratio of your x and y axis. So the ratio for x and y axis should be the same. That means 1 unit for 1 cm in x, then you have to use 1 unit in 1 cm for y as well. Alright, because if you are using the different ratio, then later when you draw the circle looks very weird. Okay, alright, then now for me, if I want to make it looks clearer, I will maybe use a small graph to help, the graph paper to help me. Right, in exam, of course, you can't use graph paper to help you, but you just try to measure it as accurate as possible. Okay, so I would prefer to have a, so you can see that this is a square. Actually, these are the squares. Okay, using the square because I want to make sure that the x and y ratio are actually the same. Okay, so maybe what I'm going to do now is I will draw the axis first. Okay, so maybe for one box is 1 unit. I'm having 1, 2, 3, 4, 5. Okay, 6. And then this one is 1, 2, 3, 4. Okay, y-axis is the imaginary part. X-axis will be the real part. Okay, so real and also imaginary. So first of all, our center of the circle is 3, 2. So 3, 2 means somewhere here. This is a 3, 2. And the radius is 1. I assume that it is 1 first. So if the radius is 1, right? So by right, your circle will pass through this point here. 1 unit away from the center. 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 So if you want, you can use a ruler even to help you, or maybe any tools that you can bring in to help you to draw a nice circle. So the nice circle will look something like this. Okay, so this is what I have for the circle for the first inequality here. So very obvious, you can see that it is a circle with the center 3, 2 and also the radius 1. Since they are saying that smaller equals to 1, smaller equals to 1 means that when you want to shade the area, right, it should be the area inside the circle. If greater equals to 1 means outside. Equals means on the line. It is on the circumference. Right, so for our equation here, inequality here, this is smaller equals to 1. Therefore, I have to shade the region inside the circle. But we need to also consider the second inequality. So for second inequality is this one, where y greater equals to 2. So if I draw the line y equals to 2, it is actually a horizontal line. So this is y equals to 2. Okay, and they said they want to consider the area y greater equals to 2. That means it will be above the horizontal line. So try to imagine, you want to find out the overlapping of the area inside the circle, and at the same time, y greater equals to 2. So the overlapping area by right should should be this one. Okay, so this is actually the area that fulfill both inequality provided in the question. And this will be our answer. Okay, all right, so this is how we answer part 1. Okay, so maybe you can have a look for part number B. Okay, so for part number B, now they want us to find the greatest value of argument Z for the points in the shaded region, given your answer in degree. Okay, so now they want us to find the argument Z for in the shaded region. So we actually need to refer back to our shaded region here. Okay, so maybe I can just copy it here and then you can have a better view, better look. So where's the greatest value of argument Z? So argument Z here, the argument Z here means that it is argument of Z from 0 plus 0i. So when you want to measure the angle of the Z, you need to measure it from the point 0, 0. So that means this is 0, 0. And then you try to move your ruler, okay, along the shaded area and see which is the last point that your line will touch the shaded region. But it cannot be away from the circle. Alright, so if you try to move your line up and down, right? So by right, your Z should be somewhere here. But I actually don't know what is the coordinate, just that you should get the value of Z. You should get a point of Z, okay, which touch the area, the shaded area, the last point, okay? The last point, wait, let me draw first. Okay, so this is the last point where you try to move the ruler, right? From 0, 0. This is the last point on the shaded area that will touch 0, 0 and will touch the shaded area from the 0, 0 point. Okay, and this is the Z. And they are asking us to find out the argument Z. So to me, this is the largest angle that I can get for argument Z. Because if your Z is here, right? Let's say if your Z is here, shaded area, right? This is the Z. You can see that the argument is small. This is the argument for this particular Z, which is smaller. So the largest one, you should try to move your ruler, go up until the very last point inside the shaded region or touch the shaded region from 0, 0. So this is the last point, okay, that we can get. All right, then now, how to find out this particular argument here? So to find out this particular argument, you need to actually try to use some property of maybe circle or triangle or whatever that you learned earlier. Okay, so for me, I'm trying to connect the Z with the center. This is the center of the circle, right? This is the center. And then I know that this is a 90-degree perpendicular line. Okay, so why I know it is perpendicular line? Because Z basically is the tangent of the circle. So tangent of the circle, when you connect the point, okay, with the center, it will actually form the perpendicular, the 90-degree line, right? 90-degree value. Then if I try to connect 0, 0 and the center here, okay, you can see basically you are having a right angle triangle. So to make the calculation easier, I will label this as O. The center, I will label it as C. Okay, and then this is particular the point Z. Okay, then now what else do I know from this diagram? I also know that since the radius of the circle is equals to 1, right? Therefore, the ZC, the length is a 1. Okay, and then what else do I have? So I actually know that I want to know the length for OC. Okay, how to know what is the length for OC? Since I know C is actually having the coordinate 3. Okay, so since we know that C is having the coordinate 3, 2, right? So I can calculate the length of OC first. Okay, so to calculate the length of OC, you just use the basic coordinate geometry knowledge to find out the length. So it should be x minus x1 plus y minus y1, right? Okay, so I'm having 3 minus 0 square plus 2 minus 0 square. So I'm having square root 13. Okay, so I know that this particular value OC is square root the thing. Okay, then now I want to find out the argument Z. So the purple color one is the argument Z. Basically, this argument Z is formed by using two small angles. One angle is the angle inside the triangle. I label it in green color. I hope that you can see it. And then the other angle will be this blue color. I label it in blue color. Right. So to get the purple color, the argument Z, basically is a green color angle plus the blue color angle. Right. Okay, so how to find the green color angle? Okay, to find the green color angle here, I label it as theta. Okay, so I will use the right angle triangle to help me. Okay, so from the right angle triangle, I know that the sine theta, what is the value for sine theta? It is opposite. Opposite is ZC, which is a 1, divided by hypotenuse. So what is the hypotenuse? It is actually OC. So OC is square root 13. So from here, right, you can get the theta. The green color angle is actually theta equals to sine inverse, then 1 over square root 13. Okay, then how about for the light blue angle? So for the light blue angle, I will use this triangle here. OC and also this one. I will draw in the light blue triangle and then I label it as tau. So from this light blue triangle, you can see very clearly that you can try to use the height. What is the height for C? The point C is 2. And then the base for the triangle is 3, right? Okay, so if you want to use the triangle, you can have something like this. Tangent tau equals to what? Equals to opposite over adjacent, which is 2 over 3. Therefore, the theta will be equals to, sorry, not theta anymore, it will be tau. Okay, so the tau here will be equals to tangent inverse 2 over 3. Okay, so some students might want to ask, if let's say I don't want to use the tangent tau, can I use any other thing? You can also use the sine, because sine tau will be equals to 2 over square root 13. Okay, the hypotenuse here for the light blue triangle is square root 13, right? So you'll get the same answer also later. Okay, so now you already find out successfully the green color angle and also the blue color angle. Therefore, to get the greatest argument Z, you just need to add them together. So greatest argument Z will be equals to sine inverse 1 over square root 13, then plus tangent inverse 2 over 3. Okay, then of course, some of you, if you didn't use the tangent here, tangent inverse, it can be also equals to sine inverse 2 over square root 13, also can. Or you can also use cos, okay, where cos inverse equals to 3 over square root 13. I think all this will give you the same answer. All right, okay, so for me, I'm using the tangent, okay. Then when I add them together, I have to put my calculator in degree mode, because in this question, they ask us to give our answer in degree. All right, so make sure you put your calculator in degree mode. Then you try to press this whole thing by using calculator. And by right, you should get your answer 49.8 degree. Okay, so basically this is how we try to get the greatest argument of Z. Right, there's no specific formula that you can use, but usually we'll try to find out all the angle or maybe some length or whatsoever. Usually it will involve some common property that you learned earlier about triangle or maybe circle and so on. All right, okay, so this is how we answer question number 5B. Okay, so now we are at question number 6. Okay, part A, using the expansion of this, sine 3x plus 2x and also sine 3x minus 2x, they want us to show that this equation is true, right? Okay, so since they already give us the hint, right? Okay, so sine 3x plus 2x and also this one, basically it is related to the identity in trigo, which is compound angle formula. All right, so it is provided in the formula booklet and this is the formula shown here. Okay, provided in the FF19. Okay, so you can see that in our case here, 3x will be the A, and then B will be the 2x. Okay, so they ask us to expand this one first. So by right, I will want to expand it first. So when I'm having sine 3x plus 2x, right? 3x is A, 2x is B. So when I expand it, I will have sine A cos B. So sine A cos B, and then plus, it is plus. Then I will have cos A sine B. So cos A sine B, sine 2x. Okay, and this is my first equation. Then second equation, I want to expand minus 1. So I'm having sine 3x minus 2x. According to the identity provided also, okay, they are the same, just that the sign plus become minus. So sine 3x cos 2x minus cos 3x sine 2x. And this will be my second equation. Okay, so after I expand them, I want to get what they want us to show here. So you can see that on the right hand side, they want us to keep sine 3x cos 2x. So I want to keep this part. I want to make sure that cos 3x sine 2x can be cancelled off. So to cancel off cos 3x sine 2x, what am I going to do is I will add the two equations together. Okay, if I want to add the two equations together, right? Left hand side, sine 3x plus 2x, 3x plus 2x, we'll get 5x. So I will get a sine 5x here. Then plus, the second equation on the left hand side is 3x minus 2x. Therefore, when I take 3x minus 2x, I will get sine x. For the right hand side, when these two terms adding together, I'm having 2 sine 3x cos 2x. Then for this term here, they already cancel each other because one is a positive sign, another one is negative sign. And now if I try to move the half over, then very easily you can see that we successfully get the equation that they want us to show. Right, so basically this is how we get the equation here. By using the compound angle formula, we have to expand them and then cancel off the unwanted term. Right, so this is how we get the part A answer. Then now let's proceed to part number B. For part number B, they want us to show that the integration of this particular term equals to this value. Okay, so we will start. Left hand side first, I'm having pi over 4 and then 0 sine 3x cos 2x. Okay, so first of all, to integrate this particular term, right, they might have many different ways to get the answer, but since in part number 1, they already asked us to prove that this particular term equals to this one, left hand side, sorry. Okay, so I will substitute the result in this part 1 into the integration later so that we can continue with the integration step. Right, so you can see from here very clearly, sine 3x cos 2x equals to this particular expression. All right, so I will just substitute into our step here. So pi over 4, 0, then I'm having half sine 5x plus sine x dx. Okay, so half is a constant. So for me, my practice is I prefer to take out the sign, the constant half. Then I want to integrate the term inside the integration here. Integrate sine 5x. Integrate sine, you will get negative cos. So just in case if you already forget the formula, you can always refer back to the formula provided in MF19. Alright, so you can see from here, integrate sine, you will get negative cos. But of course, this is just a very basic formula. You have to understand the detailed process when you integrate it. So when I want to integrate sine 5x, I will have negative cos 5x also. And after that, you need to divide the differentiation of 5x. So differentiation of 5x, you get a 5. Therefore, you have to divide it by 5. Right? Then the same thing happens. Integrate sine x, you have negative cos x. And then divided by the differentiation of x. Differentiation of x, you'll get a 1. Therefore, this negative cos x, you have to divide it by 1. Okay, then I'm having pi over 4 and also 0. Okay, so before I do any substitution, I will try to factorize out the negative sign first. Okay, so that I can try to avoid some possible careless mistake. Okay, then this is what I have. And now I will want to substitute the value. Okay, I want to substitute the value inside the integration, the term after integration. So I'm having 1 over 5. Cos 5x means cos 5 pi over 4. Substitute the pi over 4 first, right? Okay, then plus cos x means cos pi over 4. Then minus, now you want to substitute 0. So I'm having 1 over 5 cos 0, then plus cos 0. Okay, so for this question, right? Excuse me. For this question, they want us to keep our answer in exact form. So if you are using the Casio, maybe the M70 the MS calculator, right? You won't able to get the square root to the exact form from calculator straight away. So you might need to use the triangle to help you. But if you are using other calculator like ES calculator, then basically the calculator will provide you a very nice exact value answer. Okay, so just to recall back, if let's say you're using MS calculator, right, for pi over 4, the angle pi over 4, this is 1, 1 and square root 2. Okay, so just want to recall back that if you want to get any value that's related to cos pi over 4, it should be equals to 1 over square root 2, according to the triangle. And of course, 1 over square root 2 can be written as square root 2 over 2. Okay, so for those who are using MS calculator, you might need to use the basic triangle here, okay, to get the value that is related to cos pi over 4, so that you can get the exact value, okay, for cos pi over 4. So now let us continue further. Right, so for negative half, right, so I'm having negative half. 1 over 5 is 1 over 5. Okay, so cos 5 pi over 4. If you press calculator, okay, you might get a negative value because for cos 5 pi over 4, 5 pi over 4 is in second quadrant. So cos in second quadrant, okay, cos in, oh sorry, this one is in third quadrant, not second quadrant, third quadrant, sorry for that. Okay, so third quadrant. So cos in third quadrant basically should be a negative value. All right, so cos 5 pi over 4, by right you have negative square root 2 over 2. Okay, then plus cos pi over 4. So the value for cos pi over 4 will be square root 2 over 2. Then substitute 0 inside. You have 1 over 4 here. 1 over 5 here. Cos 0 is the 1. Then another cos 0 here is 1 also. Okay, then now I want to slowly rephrase my answer. Okay, I will treat square root 2 as an apple, like something like an apple. So if I'm having this and simplify this term, right, I will have negative 1 over 10 apple. That means what, negative 1 over 10 square root 2, then plus half apple, which is half square root 2. Okay, then minus this value, if you add them together, you are having 6 over 5. Then after that, if you try to simplify everything slowly, you will get this negative half. Okay, so negative 1 over 10 plus half. Negative 1 over 10 plus half, you should get 2 over 5 square root 2, then minus 6 over 5. Okay, next step, you can factorize out the 5. Okay, but you multiply in the half. If you try to factorize out the 5, but you multiply in the negative half, what will you get here is you will have 3, then minus 6 divided by 2 is 3. Then this one, 2 divide by negative 2, you are having negative 1, so square root 2. So you just try to simplify the term here by factorize out the 1 over 5, multiply in the negative half. Okay, so by right, you should be able to get the answer that they want you to show. Okay, then of course, for those who are using MS calculator, just make sure that you know how to get the value negative square root 2 over 2 from the basic triangle here. Right, so this is how we solve question numbers. All right, so now we are at question number 7. we are given this equation, differential equation, and then we know that also y equals to 1 when x equals to 0. Okay, so they want us to solve the differential equation, obtaining an expression for y in terms of x. Okay, so for differential equation, basically what we need to do is like we have to separate the variable, okay, to two different sides. So we're having two variables here. One variable is y, the other variable is x, right? So we have to separate them into two different parts, two different sides. Okay, so I'm having e2x, then dy over dx equals to 4x y squared. Okay, so I want to keep the y, everything related to y on left hand side and everything related to x on the right hand side. So when I try to move everything here, so I will have 1 over y squared on the left. Okay, then 4x divided by e power 2x, then also dx on the right. Okay, so you can see very clearly that I have successfully separated the variable y and x to two different sides. Okay, then I will just put the integration sign on both sides. Okay, so for the 4 here, some students might ask, for the 4 here, should they keep it on the right, keep it on the left? Okay, it doesn't matter basically, but for me, for my practice, usually I will keep all the constant on the right hand side, right? It is just a habit, okay? Then now we can try to figure out how to integrate the terms in both sides here. Okay, so for the left hand side, it should be no problem to integrate y power negative 2. Okay, and then for the right hand side, I want to integrate 4x, then e power negative 2x. Okay, so from here, this part you can see that on the right hand side, it consists of two different functions, the product of two different functions, where one is x, another one is e power negative 2x. So you are having the product or multiplication from two functions and you want to integrate it, we have to actually apply integration by part. Okay, so for the left hand side here, okay, for the left hand side here, we have to apply integration by part. So for integration by part formula, it is provided in MF19. Okay, but for me, I'm trying to write it out here. So to integrate it, I'm having u dv, it will be equals to uv minus v du. Okay, so to apply the integration by part formula, right, you actually need to identify which one is u and which one is v in your question. Right, so you have to try to identify, okay, which term will be my u and which term will be the dv so that I can apply the particular formula in integration by part. Okay, so to decide the u and dv, right, there's a small rule. I hope that you still remember it. According to the rule that we have, you should follow the rule LIATE rule. Okay, so where L is the logarithmic function, okay, I will be the inverse trigo. Inverse trigo in our formula will be, in our syllabus will be actually tangent inverse, inverse trigo. And then A will be algebra, such as all the constant term, all the polynomials and so on. Okay, and then T will be the trigo, and also E will be the exponential. So exponential means E power 2x E power something and so on. When the group of the function is higher, then it will be equals to U. When the group is at the lower part, then it will be dv. So now we can have a look for our question here. Okay, we are having 4x and then multiply with e power negative 2x. So 4x I will treat as one function, e power negative 2x will be another function. So 4x basically quite obvious that it is actually belongs to algebra, so it is A. Okay, and then after that e power negative 2x, it belongs to exponential function, therefore it is E. So from here you can see very clearly that the higher group will be the U. So I will let U equals to 4x. So I will let U equals to 4x. And then I will let dv equals to the remaining term inside. So I'm having e power, I will have e power negative 2x dx. So I will have e negative 2x dx. And then both sides I also have to put the integration sign. Right? Okay, so this is the first step for integration by part where I need to decide which is the group U and which is the group dV first. After you decide already, then now you can start differentiating the U. So differentiate U with respect to x, you're having du dx equals to 4. Okay, integrate 1, you have a v. Integrate e power negative 2x, you have e negative 2x divided by negative 2. The negative 2 come from the differentiation of negative 2x. So all this you need to have some very basic integration knowledge for the basic function. Okay, so take note that for the v here, for this integration here, I didn't put in the constant term yet because later I will need to substitute this term into my integration. Then only I continue the last integration, only I will include the constant c. Okay, right, so for here you can see that I didn't include any constant c here first. Okay, so I already differentiate the u, integrate the v, and now I will want to continue my step here, okay, with the integration by part. Okay, for left hand side, I just integrate normally. So integrate y power negative 2, I will have power plus 1 become negative 1 divided by the new power. Okay, so for the right hand side here, I want to apply integration by part formula. So the integration by part formula will be this one, uv minus integrate v du. So where's your u? U is 4x, right? So put in the value for x. What is your v? V is this particular term. So I will just include it, negative 1 over 2 e power negative 2x. So this is my uv. Okay, then minus integration v du. So I put minus integration of v. So this is the v, e negative 2x divided by negative 2, and then du. What is the du? Have a look here. Du equals to 4 dx, right? Okay, du dx equals to 4 so du equals to 4 dx. So I want to put a 4 here with a dx. Okay, so I try to slowly simplify my expression. Okay, so again, the left hand side, the right hand side here, basically I'm applying the integration by part formula already. Okay, so this is what I get. So now I try to simplify everything first. On the left hand side, I'm having negative 1 over y. Okay, for this particular part, I will have negative 2x, then e power negative 2x. Right? Yeah, then for this part, I need to continue to integrate it. So before I continue to the integration, I will want to simplify all the constant term first. Negative, negative become positive. Then 4 divided by 2, I get 2. So I take out the constant term 2. Then I want to integrate only on e power negative 2x. So again, continue with the integration for the next step. Okay, integrate e negative 2x, I have e negative 2x divided by negative 2. Okay, so from here you can see that I have completed all the integration term, okay, in my solution here. Therefore, at this stage, only I will put a plus c at the back. Okay, so that means I try to group all the constant term become one, where I just denote it by using a letter c. Okay, then again, simplify your equation. Right, so we already get the general solution for the differential equation. And now we need to know what is the value for c. To get the value for c, you have to use the information given here, where x equals to 0 and y equals to 1. Okay, so I want to substitute it into my integration now, my answer now. When x equals to 0, the y is equals to 1. So what happened to your equation here? So you have negative 1, substitute 1 as y as 1. Okay, then equals to substitute x as 0. So substitute x 0, this one will become 0. Then this particular term, you're having negative 1. Then plus c. So very clearly you can see that c equals to 0. Okay, then after you get the c, again, read the question again. They actually want you to obtain the expression y in terms of x. So now you need to rephrase your answer so that you get the pattern y in terms of x. Okay, so I will start from this part again. Rewrite my particular solution, negative 1 over y. There's no more c, right? C equals to 0. Okay, so to rephrase it, maybe what I want to do is I will try to put it this way. Okay, I want to factorize out the negative. Then the fraction, I can combine them together. Okay, so the negative and negative can be cancelled off, right? Then I want to get the value of y. I want to get y in terms of x. Then I will move the fraction upside down. Okay, so if you rephrase it correctly, by right, you should get this as your final answer, y in terms of x. Okay, yeah, so this is how we solve question number 7. Okay, so question number 8. By first expanding this term, they want us to show that we'll get this equation here. Okay, so since they already give us a hint to expand this particular term here, okay, but before we can start expanding, right, and to prove, to get the equation, by right, you should have equation at the beginning. So this is just an expression, right? So I'm having cos square. Okay, so I'm having cos square theta plus sine square theta. Okay, so the whole thing I want to square it. Okay, so before I want to expand it, I just want to create one equation first before I want to expand it and rephrase our expressions. Okay, so for cos square plus sine square, there's an identity that we learned earlier, right? Okay, that sine square plus cos square equals to 1. There's one identity before that we learned in AS, I think. So sine square plus cos square equals to 1. So you can see here, I'm having cos square plus sine square, which is also equals to 1. So 1, when you square it, it should be a 1 also. So by right, cos square plus sine square square, you will have it equals to 1. Okay, so this is the equation I want to start off, so that later I can get the equation that they want us to show here. Okay, all right, so you need to let this whole thing equals to 1 first because of the identity here, you can see very clearly. And after that, I want to expand the bracket. So to expand the bracket, you just expand it like you expand quadratic form equation before, right? The bracket before. So I'm having cos power 4, then plus 2 sine square cos square, then plus sine power 4 theta equals to 1. Okay, then now, what's the next step? So for the next step, you can refer to the final answer here. They want us to keep sine power 4 and cos power 4 on the left. So I will just keep the cos power 4 and also the sine power 4 on the left-hand side. Then I move the other thing to the right-hand side. Okay, so you can see that, oh, I already get something on the left, which is equally what they want us to show. And then the 1 minus, I also have 1 minus already. So now my aim is to change the last term here, the last term here become this particular expression. So if you try to compare for this answer, right, we are having double angle where I'm having sine 2 theta. Can you see the 2 theta here? Okay, whereas in our solution now, I'm having single angle, which is theta only, sine square theta, cos square theta, it is not 2 theta. So now I want to try to change the sine theta become the cos theta. Okay, so how can I change the sine theta become the cos theta? So you have to apply double angle formula in a reverse way. So just in case if you forget about the double angle formula, you can refer to MF 19 booklet. And then the double angle formula is actually here. So we are typically referring to this one, sine 2a equals to 2 sine a cos a. Okay, all right, so now, how can I substitute it? Since I know that I'm having sine 2 theta equals to 2 sine theta cos theta, right? According to the formula that we have. Okay, so now I want to change sine theta cos theta. It will be equals to half sine 2 theta. Okay, so I want to apply it in our particular step here. Okay, then before I can apply it, right, sine square theta and cos square theta actually I can write them become sine theta, cos theta with a square outside. So just now I'm having sine square theta, cos square theta, right? So if I rephrase it, I can actually factorize out the square. So it becomes sine theta, cos theta squared. Okay, so I want to change it become this pattern so that I can substitute the double angle formula in a reverse way directly. Okay, so substitute the equation inside. Okay, so sine theta, cos theta, I substitute by using half sine 2 theta and then I square it. Okay, then again, now you can further simplify the term on the right hand side. Okay, half. You need to square the half. So when you square the half, you get 1 over 4. 1 over 4 times 2, you have 1 over 2. Okay, then for sine 2x, or sine 2 theta, if you square it, you have sine square 2 theta. And you can see very clearly that we successfully get the equation that they want us to show. Alright, so this is how we get the answer for this part. Alright, okay, then now we'll proceed to part B. Okay, so to part B again, part A, since they asked us to prove some result, right? So very likely in part B, we'll want to apply this result when we solve the question in part B. Okay, so let's proceed further to part number B. Okay, so for part number B, now they want us to solve this equation, cos power 4 sine power 4 equals to 5 over 9. So again, I want to actually apply the result that they want us to show for cos power 4 and sine power 4 in part A. Substitute the result here. Okay, alright, so I'm having cos power 4 theta plus sine power 4 theta equals to 5 over 9. Okay, from part A, right, the result on the left-hand side is on the right-hand side is 1 minus half, then sine square 2 theta equals to 5 over 9. Okay, so please please fully utilize the result that they usually want us to show. So very likely that will be actually a hint for us to solve the next question. Okay, so you can see that I substitute the result in part 1 here. Then now I can slowly rephrase my answer. So sine square 2 theta equals to 4 over 9. Okay, then sine square 2 theta equals to, you bring the 2 over, become 8 over 9. Okay, then I want to take square root. Okay, when I want to take square root, right, I'll have plus minus sign. Then square root 8 divided by square root 9, which is a 3. Okay, right, then now I can start solving the equation here. I want to solve for sine 2 theta equals to plus minus square root 8 over 3, and the theta, final answer theta should be between 0 until 180. Okay, so first of all, for me, I will try to find out the basic angle first. Okay, so to find that basic angle, it should be sine inverse, then square root 8 over 3, right? Okay, so please take note for the basic angle, right? I want to make sure that the basic angle is in the first quadrant. Therefore, I will always ignore the negative sign when I press for basic angle. So I will take just sine inverse square root 8 over 3 without the negative sign. Okay, so for the basic angle that I get, it should be 70.5 degrees. Okay, then now I want to get all the possible answer for 2 theta. Okay, so to get the possible answer for 2 theta, since they are interested for our final answer, theta is between 0 until 180, right? When I want to get the answer for 2 theta, I should actually go through 4 quadrants from 0 until 360. Okay, then only I simplify my answer into theta later. Okay, so now when I want to look through for the quadrant for the answer for 2 theta, I should include the 0 until 360 degrees. That means the first 4 quadrants. Okay, all right. And now I'm interested for the quadrant with sign, positive and also negative. Okay, that means I want all the answer, okay, from all 4 quadrants. Okay, so first quadrant, I'm having basic angle, which is 70.5. So first answer is 70.5 for 2 theta. Second quadrant, the answer is 180 minus 70.5. So by right, you should have 109.5. Third quadrant is 180 plus basic angle, so 250.5. And fourth quadrant will be 360 minus basic angle, which is this one. And I already go through the fourth quadrant, then I think I should stop here. Then, of course, I want to get the final answer for theta. So to get the final answer for theta, you need to divide your answer, all the answer here by 2. Okay, so if you didn't do any careless mistake, by right, your answer should look something like this. After divide all the answer by 2. Okay, so I have this. Then 54.7. 125.3 and also 144.7. You can double check your final answer to ensure that the data lies between 0 until 180. So you can see very clearly that all our answer provided here are in the range. So very likely our answer should be correct one if I didn't do any careless mistake. Okay, alright, so this is how we solve question. Okay, so let's discuss question number 9. We are having the equation of the curve given like this. They want us to show that dy dx equals to this particular fraction. Okay, so of course we will start from the equation given first, right? Then from here you can see very clearly that we can't clearly separate the y and x to two different sides. Okay, so that means this is an implicit function and we have to apply implicit differentiation to get the dy dx. Okay, so this is implicit function, right? Where you can't really simplify or rephrase your equation y in terms of x. Okay, so to apply implicit differentiation, first of all, let's have a look for the first term here. It consists of product of two different functions. One function is y, another function is e power 2x. So when you're having the product of two different functions here, to apply differentiation, you have to apply product rule. Okay, so product rule means that, again, if you forget about the formula, you can refer to the product rule here, which is this one. Okay, uv equals to v du dx plus u dv dx. So for me, I will just apply it here. Okay, so for the first term, this is what we have. So I will treat y as the first bracket, or u, then this is the second bracket of v. So when I want to apply the differentiation, basically I'm doing it like this. Differentiate the first bracket, copy the second, then plus copy the first bracket, differentiate the second. Okay, so I will start now. Again, my first bracket is y, second bracket is e power 2x. Okay, so differentiate the first bracket, I'm having 1, right? But because this is related to y, so when I do the differentiation, I have to put a dy dx. Then copy the second bracket, e power 2x. Then plus. Now I want to do it the other way around. I want to copy the first bracket, differentiate the second. So differentiate the second means differentiate e power 2x, you will have 2e 2x. Okay, so we are now differentiating something related to x, right? It should be dx over dx, and usually we didn't write it out because dx over dx should be equals to 1. Okay, then minus. Now I want to differentiate the second term here. So again, for the second term here, you can see very clearly also it is a product of two different functions. So the first bracket or the first function is y squared. The second bracket or second function is e power x. So I'm doing the same thing here. Differentiate the first bracket, I'm having 2y. Then because this is something related to y, right? So I have to put dy dx. Copy the second bracket, then plus. Now I want to copy the first bracket y squared, differentiate the second. Differentiate e power x, you get e power x times 1. And then dx dx. So I didn't write out the dx dx also because it is equals to 1. And now I'm having equals to differentiate 2. 2 is a constant. So differentiate 2 by right, you should get a 0. Okay. And next step is you need to try to group all the dy dx on one side or the other term on the other side. Okay. So before I can express or rephrase it, I will want to expand everything that I have in the bracket first, and I want to write my equation in the nicer way first. Okay, so what can I observe from here, right? I can see very clearly that every single term I'm having e power x, which means that I can cancel out e power x first or factorize it out first. So e power x, Then e power 2x is divided by e power x, we have e power x. So this one also e power x. Okay, and then what should I do now is I want to bring all the dy dx to the other side. So these are the terms without the dy dx. I just keep it first. Okay, then equals to all the terms with dy dx. Now I will bring it to the other side. So I'm having 2y dy dx, then minus e power x dy dx. Okay, then factorize out the dy dx. Yeah, I think it is quite obvious now. The answer is out already. So if I bring, after I factorize out the dy dx, right, for the term in the bracket, I will bring it to the other side, become divide. Okay, so I'm having dy dx equals to 2y e power x minus y squared, then divided by 2y minus e power x. Yeah, so this is how we actually get the dy dx here, by applying the implicit differentiation. Okay, so in this implicit differentiation, again, I'm applying the product rule, okay, for twice, 2 times. Okay, right, so this is how we get the answer for part A. All right, then now how about for part B? Okay, for part B, they want you to find the exact coordinate. Please highlight the keyword exact coordinates. That means your final answer should be in either short form, long form, high form. It shouldn't be a long decimal number. Okay, so exact coordinate of the point on the curve where the tangent is parallel to the y-axis. Okay, so tangent parallel to the y-axis. What does it mean? Tangent means the gradient of tangent, which is dy over dx, parallel to the y-axis. So you can try to imagine if I'm having a linear line and it is parallel to the y-axis, this one means the gradient should be equals to infinity, right? Okay, and how can I get the gradient dy dx equals to infinity? That means the denominator should be equals to 0. Okay, so let's link back to our result here. We already find out dy dx in the first part. Okay, so I will write it here, dy dx equals to infinity, which also means that the result in first part that we get should be 2y e power x minus y power 2 divided by 2y minus e power x equals to infinity. So to get the whole fraction here equals to infinity, the only possible way is I'm having a very small value for denominator. Because if the denominator approach 0 or very, very small, then only I will get something divided by a very small value equals to infinity. Alright, so we will solve it using this idea, okay, where I will want to let 2y minus e power x equals to 0. Okay or not? Right, then I'm having e power x equals to 2y. And I assume that this is one equation. So to get the value for x and y, right, of course, we have to solve the equation simultaneously. So you already get one equation here. How to solve this equation with another one simultaneously to get a coordinate? Again, I have to substitute it into the original equation that we have just now, the original curve. So this is the original curve that we have. Okay, all right, so I rewrite again. My original curve basically is this one, y e power 2x, then minus y square e power x equals to 2. So this is my original equation, and this is the equation that I get from dy dx. So to get the coordinate for x and y, I have to solve them simultaneously. Okay, so I will start first equation into the second one. Okay, so e power x equals to 2y. So when I substitute y equals to y still, right? Then e power 2x, it is equals to e power x, then square. E power x is 2y. When I square, I'm having 2y squared. So minus y squared, e power x again, it is e power x, it is 2y, then equals to 2. So from here, you try to solve it. So I'm having 2y cubed equals to 2, and therefore very obvious, you can see that your answer for y should be equals to 1. Okay, then when you get the value for y equals to 1, of course, you want to get the value for x, right? So you can substitute it into either of the equation. So for me, equation number 1 is more straightforward. So I will substitute it into this equation, e power x equals to 2 times 1. So to get the x, I have to take ln both sides. Okay, and now from here, I can get the value for x, which is ln 2. Okay, so now you can see very clearly that I successfully get the coordinate for the y and also coordinate for x. Therefore, the coordinate that they want us to find will be ln 2 and also 1 in the exact form. So you can see that I keep my ln 2 in this exact form. I didn't press it into a long decimal number. Alright, so this is how we solve question number 9. Okay, so question number 10. With respect to the origin O, right, the position vector for A and B are given. And they want us to find the vector equation of the line L through A and B. Okay, so to find the vector equation for line L, right, I need passing point. So passing point can be point A or point B. So we're having more than enough for passing point. And after that, we also need the direction of the line for to form the vector equation. So what is the direction of the line in line L? Since the line L passes through A and B, right? Okay, so the direction can be either AB or can be either B. Okay, so the direction of the line, I will denote it by using P. So P, for this case, I want to use AB, direction AB. So AB means AO plus OB. AO will be -1, -2, and also 1. Then plus OB. OB will be actually 0, 3, 1. So the P that we get from here is actually -1, then 1, and also 2. Then we can further writing out the vector equation of line L. So we'll use the R. Okay, so R equals to passing point. Passing point can be either the point OA or the point A or point B. So you can use the vector equation OA or OB here. Okay, so I'm using OA here. 1, 2, and -1. Then plus T. Then the direction of the line. So the direction of the line will be -1, 1, and also 2. Okay, so this will be our vector equation for the line M. Okay, so for your information, right, if you don't want to use point A as a passing point here, you can use also point B as a passing point. And also for the direction, you can actually using 1, -1, and -2. If you are using BA, okay, because BA is actually also the direction of the line. Alright, so it is not wrong that you are using 1, -1, and also -2 with the passing point B. So this is what we have for 10A. Alright, then now let's proceed to part B. For part number B, they are saying that point C lies on line L and also AC equals to 3AB. They want us to find the position vector of C. Okay, so first of all, you need to know that C lies on L. When we are having any point, any particular point that lies on the L, lies on the line, basically OC. Okay, so the OC will be having the vector equation, the position vector of the C will be equals to the vector equation of line L. It is because of, since the C lies on the line L, right, if you substitute any value inside the vector equation, right, as example like T, if I substitute one particular value inside this vector equation, then the vector that I get is actually the position vector of the point that lies on the line L. So this is a small knowledge that you need to know before you can continue with the question. All right. Okay, so I will let OC equals to the vector equation line L. But for me, I will just change the T become some other thing else. So I'll change it become mu. So I'm having 1 minus mu, 2 plus mu, and also -1 plus 2 mu. Okay, so just to emphasize here, this is same as the vector equation because the point C lies on the line L. Okay, so since you know OC equals to this particular vector already, right? So now I want to use this information to continue the calculation to get the position vector of C. AC equals to 3AB. By using all the vector provided here, AO is -1, -2, and 1, right? And then what is the OC? OC is 1 minus mu, 2 plus mu, and then -1 plus 2 mu equals to 3AB. So 3 times of AB. So AB is -1, -2, and 1. Then plus OB. What is the value for OB? 3031. Okay, if you try to simplify both sides here, by right, you should be able to get negative mu, and 2 mu equals to -3, 3, and also 6. Yeah, so from here, I think very obvious, and you can see that mu can be equals to value 3. Since you know that mu equals to value 3 already, right, you can substitute it into the position vector of C, okay, so that you can get the position vector of OC. So what is the OC here? So by right, if you substitute mu inside the equation into the vector column vector form, you are having OC equals to -2i, then plus 5j, 2 plus 3 is a 5, and also 1 plus 2 mu. -1 plus 2 times 3, you're having 5, so it will be given, you will be getting 5k. Therefore, this is your vector equation of C, where it should be -2, 5, and also 5. Alright, okay, so this is how we solve part B, and let's continue to part number C. Okay, so for part number C again, they want you to find the possible position vectors of the point P on L such that OP equals to square root 14. So one more time, highlight the possible position vectors. So that means you might have more than one answer, okay, for this question. And after that, point P also lies on L again. So like what I mentioned just now, right? If you're having the line L, if you're having point P, then OP will be equals to the vector equation of L. Right, so again, I will want to write out the P first, my position vector for P. So position vector of P will be equals to the vector equation line L. So now I want to use another maybe letter and another unknown. So maybe I'm using S. Okay, so 1 minus S, 2 plus S, and then -1 plus 2S. Again, just to let you know that this is actually same as vector equation because of the point P lies on the line L. Okay, therefore the position vector of P will be equals to the vector equation. And now let's continue further. I know that OP can be written like this. Then now they give us the information where OP equals to square root 14. For this one, OP means the length of OP or the modulus of OP. So they are telling you that modulus of OP equals to square root 14. How to find out the modulus of OP? Okay, so modulus for OP is the length of OP where you are having the square root of x component square plus the y component square plus the z component square equals to square root 14. Okay, so the square root for both sides can be cancelled off without the square root, right? And now we will start to expand everything. So try to expand all the brackets here. 1 minus x squared, 2 plus s squared, and also -1 plus 2s squared. So if you didn't do any careless mistake, I think this one you have to do it very carefully to avoid any possible careless mistake here. Equals to 14. Now I want to simplify everything on the left hand side. So I'm having 6x squared, then minus 2s, then minus 8 equals to 0. I will get the quadratic equation in terms of s. Then I can further simplify it now. And I want to solve and get the value for s. Okay, so to get the value of s, what am I going to do now is I try to factorize them. 4, then 1. After that, minus 4 plus 1. So from here, I think you can see very clearly that I actually get two values of s, where s can be equals to 4 over 3 and also s equals to -1. Okay, then now I want to substitute the value of s into the position vector of OP. Then I can find out the exact value and the real value for the position vector for the point P. Correct? Okay, so I'll substitute my value of s into the position vector equation. Position vector for the P. Okay, so now I substitute it. When s equals to 4 over 3, what is the OP that I get? So the OP that I get when s equals to 4 over 3 will be -1 over 3i, then 10 over 3j, and also 5 over 3k. Then I have another possible value for OP. When s equals to -1, if you substitute into the position vector of P, then by right you should get 2i, then plus j minus 3k. So I think this will be the possible answer for the position vector of point P. Okay, you are allowed to write in IJK form, no problem, or even if you want to write in the column vector form also can. Right? Yeah, so this is how we solve question number 10. Okay, so we are now at the very last question of this paper, question number 11. The equation of the curve is given y equals to square root tangent x, and then the x is defined between 0 and pi over 2. Okay, express dy dx in terms of tangent x. Okay, so they want us to have the answer in tangent x and verify that dy dx equals to 1 when x equals to pi over 4. Okay, so I think this is important. Dy dx in terms of tangent x. Alright, so before we start, we have to rephrase our equation into this pattern first, where y equals to tangent x, square root, I will put it as power half. Okay, so this is to make our process of differentiation easier. Right, then now I want to do the differentiation. To find the differentiation dy dx, just follow some very basic concept that we learned before in differentiation, where I'm having a bracket with the power here. For differentiation, I need to pull the power in front, become half. Copy the bracket. Tangent x, power minus 1 become -half. After that, I need to differentiate the thing inside the bracket. Differentiate tangent x, what do I get? I get secant square x. Okay, so I'm having secant square x. So from here, you can see that I have completed my differentiation, but they want us to express dy dx in terms of tangent x. Therefore, I have to try to change my secant square become something related to tangent. Again, if you can't remember anything that can be applied, then you can refer to the trigonometric identity provided in MF 19 and try to look for secant square and tangent. So you can see that secant square can be written as 1 plus tangent square. So I'm going to substitute this one in my solution here. Okay, so for secant square, I want to substitute it by using tangent square plus 1. Okay, so for this one, secant square, I'm having tangent square plus 1. Then I want to divide it by, so the fraction is a 2, right? So I'm having a 2 here, and then tangent x power -half, I can write become tangent x square root. So you can see that now my dy dx is having the answer here in terms of tangent x only. Okay, without the secant square. So it is tangent square x plus 1 divided by 2 square root tangent x. Okay, so this is what we have for part number 1. Part A. Okay, proceed to part number B. Now they said that, oh sorry, I haven't completed the question yet, right? After I find the dy dx, I need to verify that dy dx equals to 1 when x equals to pi over 4. That means now you have to substitute your value. When x equals to pi over 4, what do I have for my dy dx? Okay, so I'm having tangent pi over 4 square plus 1 divided by 2 square root tangent pi over 4. Okay, so from here I know that tangent pi over 4 is a 1 square plus 1, then divided by 2 times 1. Therefore, you actually get the answer for dy dx equals to 1 when x equals to pi over 4. Yeah, so I think this is a complete question for part A. We need to verify the dy dx equals to 1 first. Okay, then after that, we continue to part number 2. So they are saying that the value of dy dx is also 1 at another point on the curve where x equals to a, as shown in the diagram. So from the diagram here, you can see that at x equals to pi over 4, your value of dy dx is equals to 1. Then at the same time, when x equals to a also, if you substitute into the dy dx, you will get the value also equals to 1. Okay, and now you can see from the diagram, a basically is a value smaller than pi over 4. This will be useful for you to answer the question later. All right, so we have to fully utilize the diagram provided in the question actually. Okay, so from here, I actually know one information. Okay, a is a value smaller than pi over 4. So for part B, right, they want us to show that we will get this one, t power 3 plus t squared plus 3t minus 1 equals to 0, where t equals to tangent A. So now, how can we prove this one? Since this question is related to dy dx equals to 1, so I will want to start from the result that I get just now, where dy dx equals to 1 here. Okay, all right, so I'll start with dy dx equals to 1. So I'm having dy dx equals to 1. Okay, and then what's my dy dx just now? So dy dx just now is actually tangent square x plus 1 divided by 2 square root tangent x. Okay, so I'll put in here tangent square x plus 1 divided by 2, then square root tangent x, and it is equals to 1. But in this question, right, they said dy dx equals to 1 when x equals to a. That means all the x here inside the equation for dy dx, I have to substitute it by using the a. So instead of x, I put it as a. So I'm having tangent square a plus 1 equals to 2 square root tangent a. And now they are saying that t equals to tangent a, right? So for t equals to tangent a, I substitute it here and I wish to get this particular polynomial. Okay, so no matter how, I try to rephrase it slowly first. Okay, tangent square a means I'm having t squared. Because t equals to tangent a, right? Then plus 1 divided by 2 square root tangent a means square root t equals to 1. Okay, all right. Then how can I further simplify it? I want to move the denominator to the other side. So I'm having 2 square root t on the right. Okay, in my polynomial here, I don't see any square root. Therefore, I have to get rid of the square root here. Excuse me, square root t here. So to get rid of the square root t here, I have to square the equation both sides. And then further expand it. Okay, therefore, when I further expand it, right, and rephrase everything, I will get a polynomial as well. But sadly, if you have a look for the answer that I get, I'm actually getting a cubic equation, the quadratic equation with t power 4. But what is the polynomial that they want us to get is actually t power 3. That means from this t power 4, we need to think a way to reduce it, become t power 3. So how can we reduce t power 4 become t power 3? That means we might need to carry out long division by using a suitable factor. All right. Okay, so what's the suitable factor just now that we are using? We can use. Okay, so again, we recall back to the answer that we get in part A just now, right? I'll write it here. Okay, just now in part A, we actually know that dy dx is equals to 1 when x equals to pi over 4. Okay, which means that tangent pi over 4 equals to 1. Okay, so for tangent pi over 4, if we substitute tangent A, okay, it is also a root, right? So tangent A, I can actually denote it by using t. So from here, you actually know that t minus 1 is a factor for the equation dy dx equals to 1. Correct or not? Because when you substitute tangent pi over 4 or equals to 1 inside the equation, the polynomial here, you can get, okay, it is actually one of the solution. So that means if let's say t equals to 1, you bring the 1 over, it will become t minus 1. So t minus 1 will be actually the one of the factor for the equation dy dx equals to 1. What's the equation for dy dx equals to 1? Because just now you did rephrase it, right? Which is this one. After you rephrase, this is what you get. All right. Okay, so now I'm having a quadratic equation, and if I want to reduce it, become a lower degree polynomial, I need to apply long division by using the factor, by divide it using factor. So that means now I want to divide, I want to take the polynomial and apply long division. So 0t power 3 plus 2t squared minus 4t plus 1. And the root that I have is t neg minus 1. So try to find out something. Something multiply with t, you get t power 4. So the something will be t power 3. Okay, so 0 minus 1 power 3, 1 minus 1 t power 3, I'll get positive t power 3. So bring down the t square. Something multiply with t to get t power 3. So the something here will be t squared. Okay, so t squared multiply, I have t power 3, then minus t squared. Then 2 minus minus 1. So I'm having 3t squared minus 4t. Okay, then something multiply with t to get 3t squared. So the something should be 3t. So 3t multiply with t, I get 3t squared. Okay, then 3t multiply with negative 1, I get negative 3t. Okay, so negative 4 minus negative 3, I get negative t plus 1. So here should be negative 1. And you can see that I actually get the long division without any remainder because the t minus 1 is one of the factor for this polynomial, right? Okay, since I know that the equation dx dy dx equals to 1 is can be denoted by this particular polynomial, right? Okay, so you can see since t power 4 plus 2t squared minus 4t plus 1 equals to 0, so this polynomial can be written as the quotient multiplied with divisor to get back the polynomial, right? So I'm having t minus 1, t power 3 plus t squared plus 3t minus 1 equals to 0. Okay, so if you're trying to solve this particular equation, t minus 1 equals to 0, and from here, you successfully get the equation where t power 3 plus t squared plus 3t minus 1 equals to 0. And this is exactly the polynomial that they want us to show. Okay, so this is how we actually try to reduce the polynomial the original polynomial with t power 4 to reduce it become the polynomial with t power 3. So to reduce it, you have to apply long division. But of course, before the long division, you need to know what is the factor for this particular polynomial. Alright, so this is how we solve part B for this question. And now let's proceed to the next part. Okay, so for the next part, right, they want us to use this iterative formula, determine the value of A correct to 2 decimal places, giving the result of iteration to 4 decimal places. Okay, so now I have to use the iterative formula. First of all, I need to decide the initial value for the A first. What is the initial value that is suitable for this question? So there are many values that you can use now. All right, but for me, to be on the safe side, what I'm doing here is I try to observe the diagram again. And I know that the A should be a value smaller than pi over 4. And I assume that it is like very close to the midpoint between 0 until pi over 4. To me, I assume that it is quite close to the midpoint, the center of 0 until pi over 4. Therefore, the initial value I'm using is pi over 8. For you, you can actually use any value that you like. But of course, one of the hints that you can refer is this one. Okay, try to use some value that is smaller than pi over 4. I think that will help you in finding out the answer faster. Okay, all right, so for me, myself, I'm using pi over 8 as initial value. All right, so I go back to the question here. So my A1 is pi over 8, which is the initial value. And then to find out the A2, what am I doing here is I need to substitute it inside this iterative formula. So I'm having 1 over 3, and then 1 minus tangent square pi over 8 minus tangent cube pi over 8. Okay, so I have to press it by using calculator to get the answer. First of all, I need to key in the calculator, the formula into the calculator, definitely, right? This equation is quite complicated. We have to make sure that we key in it correctly. So first of all, I want to have tangent inverse 1. So shift tangent, I will have tangent inverse 1. Inside, I want to put a fraction with a 3 at the denominator. Okay, then on top, I'm having 1. Then minus tangent x squared. So tangent x squared, what am I doing now is I will want to open a bracket with tangent x, then square. Okay, then minus tangent x cubed. So again, bracket, tangent x, then cube. Okay, then close bracket. Okay, so make sure that you double check and to make sure your equation is correct before you want to apply, okay, to find out all the iteration formula. So I double check again. I'm having 1 minus tangent square x, okay, then minus tangent cube x divided by 3. So I think this is correct already. Okay, all right. So now first value is pi over 8. Oh yeah, before I forget, make sure that your calculator is in terms of radian mode, in the radian mode, not the degree. Okay, it is in the radian mode. So I will press calculate. So first value, I want to key in pi over 8. So I'm having pi divided by 8, and then I press equal sign. So this is the first value that I get, 0.2473. 0.2473. So I write here first, 0.2473, correct to 4 decimal places for the iterative, each iteration. Okay, then after that, I want to get the A3. So of course, A3, you also substitute this particular A2 into the equation, into the iterative formula. So you don't need to write out the formula anymore. You just directly press calculator. So press calculate. Then now key in the value 0.2473 and equal sign. Then you get the next value, 0.2976. So again, I want to make sure that my answer is in 4 decimal places, 0.2976. So I will repeat the process until I get the answer with 2 decimal places repeated. Okay, so press calculate again, 0.2976. Then you press the equal sign, 2844. So 0.2844. Haven't repeated yet, right? The 2 decimal places answer. So just continue again until you get the repeated 2 decimal places answer. So calculate again, 0.2844 equal sign. So I'm having 2883. So 0.2883. If you try to observe, 2 decimal places answer for this one is 0.28. So this one is actually 0.29. So they haven't repeated yet. Okay, so you still need to continue until you get repeated 2 decimal places answer. Okay, so press calculate again, then 0.2883. 0.2883, then equal sign. So I'm having 2872, 0.2872. Okay, so if you double check again, this answer is 2 decimal places is 0.29. So by right, you already can see the repeated value in 2 decimal places answer. Okay, for me, usually I prefer to double check one more time. So usually I will carry out the iteration one more, okay, to make sure the final answer. So calculate again, 0.2872. Then press the equal sign. So I'm having 0.2875. Okay, so again, double check 2 decimal places answer. So very obvious, you can see that it is equals to 0.29. So from here, you can actually make a conclusion for yourself where the root is equals to 0.29. So make sure you write your final answer for the root or the A correct to 2 decimal places. Because you can see it is requested in the question, right? Answer is 2 decimal places, but for the iteration, all must be 4 decimal places. So you can see that all my iteration, I put it in 4 decimal places besides the initial value. All right, yeah, so this is basically how we use the iteration formula, okay, to get an answer for the root. Right, so please make sure that you substituting the first initial value, which is not too far away from the root. You can always refer to the diagram provided if let's say they did give you any diagram. And after that, please make sure that you key in the calculator, the formula in your calculator correctly. If you have any formula, wrong formula key in, then of course you can't get the answer. That's the first thing. And second thing, please make sure that any iteration formula that involve the trigo, please make sure you put it in a radian mode, because all the value that we insert here will be in the unit of radian, not degree. So you have to ensure it is in the radian mode for your calculator. Alright, so this is how we solve this particular paper. Alright, so thank you very much for watching the video.